Most PLC programming tutorials for beginners have the same problem. They teach you one program in isolation, and then they stop. You watch a motor start-stop rung get built, and at the end you still do not know what to learn next, or why the scan cycle matters, or where a timer fits in. You have seen a thing. You cannot yet do the next thing. This video is different. It is not one example. It is the path, the order to learn PLC programming in from never having touched one to a small working program. And every step is done live in a free browser simulator. So you're actually programming along, not just watching. Here is the whole path for stages in the order that actually builds understanding. Stage 1. How a PLC thinks. The scan cycle. Before you write any code. Stage 2. Your first rung. A contact, a coil, and the seal-in that makes it a real motor circuit. Stage 3. Timers and counters. The two function blocks you will use on almost every machine. And Stage 4. A small project that combines them with an objective graded automatically. Each stage builds on the one before it. By the end, you will not just have seen a PLC program. You will understand why each piece is there. Let us start with the part most tutorials skip. Stage 1. How PLC thinks. This is the single most important idea for a beginner, and most tutorials skip straight past it. A PLC does not run your program top to bottom once, like a script, and then quit. It loops, thousands of times a second. Each loop does three things. Read, it samples every input bit into memory, all at once, taking a frozen snapshot. Execute, it solves your ladder logic against that snapshot, top to bottom, left to right. Update, it writes the solve coil states out to the physical outputs. And it does it all again. Read, execute, update, repeat. Almost every beginner bug, a coil that flickers, a one-shot that does not behave, comes from not understanding this loop. In the simulator, you can watch a scan counter tick up while the logic runs, so the loop stops being abstract. Stage 2. Your first rung. We start with the simplest possible thing. A normally open contact on the left, wired to a coil on the right. When the contact is true, power flows across the rung and the coil energizes. Press the input, the output comes on. Release it, the output drops. That is a rung. Now the move that turns it into a real circuit. The seal-in, also called a latch. We add a second contact in parallel with the start button, but this contact is driven by the motor's own output. So when you press start, the coil energizes. That coil's own contact closes and holds the rung true, even after you let go of the start button. Then a normally closed stop button in series breaks it. Start, stop, seal-in. That three-part pattern is the foundation of nearly every motor circuit in industry. Build it once, and you have a backbone. Stage 3. Timers and counters. Two function blocks, and you will use them on almost every machine you ever program. The on-delay timer, TON. You give it a preset time, say 5 seconds. When its input goes true, it starts counting. When the elapsed time reaches the preset, its done bit turns on. Use it to delay a motor start or to wait before raising an alarm. The counter, CTU, count up. Every time its input sees a rising edge, it adds one. When the count reaches the preset, its done bit fires. Use it to count parts off a conveyor or cycles of a machine. We drop both into the same editor, set their presets, and wire their done bits into the logic. Preset, current value, done bit. That is the whole mental model for both. Stage 4. A small project. Now we combine everything. A start-stop seal-in for a conveyor motor. An interlock, a normally closed contact from a guard, or an overload that must be closed before the motor can start. And a timer that runs the conveyor for a set time after a part is detected, then stops it. One short program with a clear objective. And here's the part that makes this a tutorial and not just a demo. We press grade. The simulator's auto-grader drives inputs at your program. It presses start, trips the interlock, runs the timer, and checks your outputs against the spec. Then it tells you pass or fail, and if you failed, the reason. The interlock did not block the start. The timer fired early. That feedback loop is exactly what turns watching tutorials into actually being able to program. Let me be honest about what this costs, because the answer is mostly nothing. The simulator runs in your browser. no install, no license. It works on a Chromebook in a lockdown lab. 2 scenarios load with no account at all. A free account, no credit card, unlocks more. Everything in this tutorial, the scan cycle, the rungs, timers, counters, the graded project, you can do for free. What the Pro upgrade adds is the full structured curriculum. It takes this path all the way through 40 scenarios, plus progress tracking and a completion certificate for your portfolio. So free is the genuine beginner on-ramp. Pro is the full course. That is the path. Scan cycle, first rung, timers and counters, a graded project, in order the way it actually builds. Start it free at plcsimulationsoftware.com/learn-plc-programming. Open the editor at plcsimulationsoftware.com/plc-simulator. Follow along rung by rung. Links in the description. Next video compares the free online PLC simulators head-to-head. Honestly, including where the others are the better pick. Subscribe. New video every Tuesday. See you in the next one.